Today I'm going to walk you through the basics of the broadcast air chain. This is one of the fundamental videos in a series about broadcast basics. I've talked about the FCC and the basics of RF, and now I'm diving into the equipment and how you get audio to the audience. When radio was invented back in the early 20th century, there were little to no expectations about how a radio station would be built. They used what they had on hand and the knowledge about electronics that they had at the time. A lot of the technology came from the telephone industry, and that would basically be the same for the next 50 years. So when I talk about the traditional radio station, I'm going to be talking about the setup for stations from about the 1970s to the late 1990s. The 1990s and 2000s really changed how radio was done, yet kind of was mostly the same. In our traditional radio station setup, we are going to start with the microphone. The microphone has its own history, and that's outside the scope of this video, and I'll cover that in another video. But the microphone converts your voice or sound to electrical voltage. If you look inside of a microphone, you'll see a flat piece of metal. Basically, that piece of metal vibrates with your voice, and a magnet picks it up, and that vibration creates a small amount of electricity. That electricity then travels down a cable to a console. Now, the console also usually has other sources connected to it. They could be CD players, computer outputs, cart machines, reel-to-reel tape players, other microphones, telephone lines, or a remote broadcast line. Anything that has audio that comes over a wire can be connected to the console. So let's talk about the console itself. It takes those different sources and allows an operator to raise and lower the volume of a specific source, mix different sources together, like a microphone and music from a CD player, and then outputs it as a combined source of audio. Usually this is called the program bus or program feed. Some consoles can have multiple program buses in order to feed other stations or other things, such as maybe a syndication feed or something like video.
Haha, there we go. How's that?
That program audio feed is then fed into the studio to transmitter link. This is typically called the STL. STLs come in a couple of different varieties. You have the STLs that are point-to-point, like a microwave link or even a cable that the station has run from the studio to the transmitter room. Some STLs follow a more complex path, such as ones that go through the internet or through a satellite feed. It's basically just getting the audio from the studio to the transmitter in real time. Now, once the audio is at the transmitter site, we've got to do something with it. So we've got to get that audio ready to be broadcast. We feed the audio from the STL into the audio processor. The audio processor has two roles: make an aesthetically pleasing sound for the listener and constrain the audio to legal limits for the radio station. The audio processor passes the audio to the exciter. This is where the audio gets turned into RF. The exciter generates the RF, mixes in other services that are present, such as subcarriers, generates the RF, and passes it to the amplifier. Not all radio stations need an amplifier. Maybe some small LPFMs can get away with exciters only. And really, all an amplifier does is take a smaller amount of RF, like 50 watts, and boosts it to 5,000 watts. Some transmitters have all this combined into one physical unit. Some have it broken out into separate units. But either way, the amplifier turns the RF up to the right level and sends it on its way. The exciter and amplifier combination is considered the transmitter. The coaxial cable, or coax, takes that RF from the transmitter and transports the RF up to the antenna. Now, usually the antenna is located a couple of hundred feet above the transmitter on a tower. For FM stations, the tower is nothing more than a support structure to get the antenna placed at the right height. For an AM station, kind of depends on if it's a directional antenna or a non-directional, but you could have another box after the transmitter that distributes the RF power to the different antennas to create a pattern. But for an AM station, the tower is the antenna. The antenna takes the RF and basically sends it off into the ether, the atmosphere, for you to pick up on your car or home radio. Now, over the last 100 years, there have been a lot of innovations that have come into the radio industry. Early on, it was the telephone company that had a big influence on the engineering of radio stations. But then the recording industry started to have its own influence. And in the last 10 to 15 years, the computer industry has really made an impact. Today, products like Telos's Livewire or Wheatstone's Wheatnet have taken audio in a radio station facility and made it so much more flexible with how it's routed and transported. Back in the day, radio stations that had multiple studios would have large looms of cable, big ones. Each source would have its own cable, and there would be a limited amount of cables between studios that would allow you to move audio around. But with audio over IP, you can have all of your sources available to all of the facility all of the time. We've also changed how audio is transported to the transmitter. STLs today are usually IP-based systems that turn the audio into a stream of data that gets turned back into audio on the other side. One product from Gates Air allows you to feed the audio data over 2 separate network connections, then splices them back together on the other end to make sure that you have a stable and consistent stream of audio. Now, there are a lot of other little parts for broadcasting that I'm not covering today, like subcarriers and RBDS or RDS and HD radio. But this is the overview of the air chain of a broadcast radio station. In future videos, I'll break down each step that I talked about today and get into a little bit more depth on each step. But next week, we're going to talk about some basic troubleshooting. So if you find yourself at a radio station and off the air, you can have a better idea of what is happening and how you could potentially fix it. Be the hero. Why not? Thank you for watching this video. I appreciate you being here. I really do. Thank you for taking the time. And if you enjoyed this video, watch more in this series with the Broadcast Basics playlist. Or maybe you want some good old-fashioned driving the Polaris in the snow with this video. Or maybe this video that the algorithm thinks you'll like. Either way, thanks for watching, and until next time, stay safe, stay healthy, and I'll see you in the next video.